In this lesson, we're going to look at angles involving parallel lines. I've got it pre-filled in for us because there's a lot of writing involved, at least on my part, and just to save some time, I can just explain it since I've got it pre-filled in. We already, in a previous lesson, looked at some of the angle theorems. Here's just a reminder of them. We saw what a complementary angle was, adds up to 90. We saw what a supplementary angle was, it adds up to 180. We saw what opposite angles were. Opposite angles are equal to each other, so ones that are across from each other. We saw the angle sum theorem, which says that triangles always add up to 180. All right, here's an example using the angle sum theorem. Just if you know the two of the three angles in a triangle, you can always find the last one by subtracting. So if we know 50 and 35, we can subtract that from 180 and we get 95. If we know that we've got an equilateral triangle, which is what we have in this one, that means that every one of these angles here would be x, since equilateral triangles have equal angles, and so we can do 180 divided by 3 equals 60. Okay, isosceles triangles, remember, those are ones that have two side lengths the same. That's what these little marks here mean. So this and this means that they're the same length. They also have equal angles at the bottom. So if we know one of the angles of an isosceles, we only need one of the angles of an isosceles triangle. It doesn't even have to be the doubled up one or not. We can always find out the missing angle of an isosceles triangle. So, for example, if I know that I've got an isosceles triangle and the non-doubled up angle is 80, then I can subtract that from 180, which all triangles are, and divide it by 2 to find out that these ones are each 50 degrees. Here's some other examples using the opposite angle theorem, just to give us a bit more, again, I'm going to go fast, but you can always pause this, you can rewind it, do whatever you need until you get it. But here's some kinds of questions you might see involving opposite angles. If we know that these two angles are opposite to each other, these two here, then we know they're equal to each other. So then we can just make them into an equation. We can take that and put it on one side of the equal sign, take that from the other side of the equal sign, and then just go back to our equation solving skills, techniques, to isolate x. So I could subtract 2x from each side and add 2 to both sides and so on. Just read through this answer and you'll see that x ends up having to be 9. So then we can solve for x. We can even find out what the angle has to be. Once we know that x is 9 from using our equation solving, then we could substitute it back into the original sides of the equation to find out, oh, okay, each side had to be 25 degrees. Here's just another example I made up with the same idea, except this one wasn't using opposite angles, it was using supplementary angles. So I made up a question where I just said, let's ignore this part for now. I'll undo that in a second, actually. I'm going to hide this for a second. All right, so if we've got these two in a straight line like this, we know they add up to 180. So then we can just literally add this and this together and say it equals 180, and we've got ourselves another equation that we can solve, right? So there's the steps showing that. Rearranging things a little bit, again, just working through until I get it all worked out. It goes down until I figure out that x equals 20 degrees. Once I know that x equals 20 degrees, then again, I could substitute it back in and find out what these two different angles are. As you can see, putting 20 back into the first one here gets me 112 as that bigger angle. Putting 20 into the second one here gets me 68 for the second one. So again, going fast, feel free to pause at any time, but just some of the things we can do with it. Here are some things to do with angles involving parallel lines. So GSP, what it's talking about right here, stands for Geometer Sketchpad. And that's just, it's just a dynamic geometry software where it shows angles moving around. It's a great tool, but I think we can get by without that for today. I'm just going to explain things. So here's some definitions, so a terminology you need to know though. A transversal, darn it, come back. A transversal is a line that intersects two or more other lines. All right, so that's what a transversal is. It intersects two or more other lines. In other words, it cuts across them. This here is a transversal because it's going across those two other lines. Remember, opposite angles are just OAT for short. If lines are, well, these ones are parallel, so I'm going to jump ahead. I know these two lines are parallel because they look parallel. In other words, they look like they never touch, but also I'm being told they're parallel because you see these arrows on here I'm highlighting in red? The arrows like that indicate, that's a way of telling me that these two lines are parallel. So these are two parallel lines and they're being intersected by a transversal, being cut across by a transversal. Then with that, we can start to put things together and pick out angles that are the same or that have relationships to each other. For example, A and D are opposite angles, and we know that opposite angles are equal to each other. So A is going to be equal to D. But we can also see that B and C are opposite each other, and Y and W are opposite each other, and Z and X are opposite each other. Each one of those pairs is going to be equal. Remember, straight angles are called, we use SAT for straight supplementary angle theorem. Here's some other connections between them. We can see that C and D, I won't recolor them for this, but C and D form a straight line. So do A and B. So do Y and X. So do Z and W. Can you see other ones? Because I can see other ones. There's also A and C. There's B and D. There's Y and Z. There's X and W. They're also straight angles. Then we have corresponding angles. Now, we're going to get into a group of three patterns here. We've got the F pattern, which is corresponding angles. We've got the Z pattern, which is alternate angles. And we've got the C pattern, which is interior angles. And these are all specifically to do with parallel lines that are cut across by a transversal. So the first one, corresponding angles. They form an F pattern. Now, I don't know if you can see that very well. I'm going to highlight it again in red, this blue, this one here. See, if you can see me coloring in this blue line with a red one, it sort of makes this F shape. But I can also flip this F upside down, so you have to use your imagination a bit. If I flip this F upside down, angles that are on the same side of parallel lines, so in other words, have the same position with respect to the transversal and the parallel lines, are equal to each other. So X and X here, these two angles here are equal to each other. They're both above the parallel lines and they're both on the right-hand side of the transversal. X and X in this one highlighted in green are also equal to each other. They're both below the parallel lines and on the left side of the transversal. So any angles that are in the same position with respect to the transversal and to the parallel lines are equal to each other. And again, that's called corresponding angles. Alternate angles make a Z pattern. So you can see that Z I've already drawn on here. So, and again, it could be a frontward Z or it could be a backward Z, but they're always between the two parallel lines. You always find alternate angles between the parallel lines, and they're also on opposite sides of the transversal, as you can see in these two examples. They are also equal to each other. Interior angles is the last one. They have a sum of 180 degrees. In other words, they add up to 180 degrees. It's called a C pattern, and you can see why. It's highlighted in blue there. It sort of looks like a C the way it's drawn. Again, sometimes that C is flipped backwards, but it's still making that C pattern. Again, how do we know what they are? Well, they're between the parallel lines, but this time they're on the same side of the transversal. Now, these ones are not equal to each other. they have a sum of 180. Whoops, they add up to 180. So, corresponding angles are equal to each other. Alternate angles are equal to each other. Interior angles add up to 180. So, you might have to pause this, rewind it, or just review it, read it on your own. You want to get familiar with this and get it in your head, all right? But here are some examples. We can use these relationships to determine the measures of other angles when one angle is known. So, this one's already filled in for us, although maybe I'll get rid of it. We don't have to have it filled in, do we? Doesn't take that long to fill it in. All right, so what do we have? Well, we know that 48 is up here, okay? Well, good. If that's 48, then W also has to be 48, doesn't it? And that means that X plus 48 has to equal 180, because these ones, X and 48, whether you're looking whichever way you go, makes a straight line. So this one has to be 180 minus 48. So that's 132. And what else? Well, W and Z are alternate angles. Alternate? No. Sorry, my bad. W and Z are corresponding angles, but that means they're equal. Once again, they're equal. W and Y are alternate angles. So they are also equal, that's 48. But I also know that Y and Z are opposite angles, so I could have got it that way as well. So there's different ways to come at it. But if you know you've got parallel lines and you know you've got a transversal, as long as you've got one angle, you can pretty much figure out all the other angles. Are lines A and B parallel? How do you know? Well, they don't look parallel, but as you can see, since I've already written it in, they're not parallel because if they were parallel, this would be forming, well, it does form an F pattern. This is like, they should be corresponding angles, which means they should be the same, but they're not. So that proves, since they're in the position where they should be the same, but that they're not the same, that proves that they're not parallel. Determine the angle measure indicated by each letter. Which relationship did you use? All right, well, here's 85. Using the Z pattern, this one also has to be 85 because they're both between the parallel lines on opposite sides of the transversal. For this one, we got 120 degrees, and that means that this angle here is corresponding. It doesn't have anything marked here, but these two angles here, the ones I've highlighted in green, correspond, so they're the same, they're 120, and since this one's 120, that means that this one has to be 60 because these two have to add up to 180. This one is 71 degrees, which means that this one has to be 180 minus 71 since they add up to a straight line, 109. These two, this one and this one, 71 and Z, form a C pattern. So they also add up to 180. And so I could just subtract 71 from that. Or I could say that, if I want to come at it a different way, I can also say that Z and Y form the Z pattern. They're alternate angles, so they're equal. So that's another way of knowing that Z has to be 109. And Z and X are opposite angles, so they've got to be the same. But Y and X are corresponding angles, so they have to be the same. Again, different ways of coming at it, but I can tell from any way I come at it that it's always going to be the same answer. In this case, 109 for X.